All right, here is the second part of our preliminaries videos. And here we'll talk about the graph of an equation. So anytime we have an equation using the variables x and y, the graph of that equation is the collection of all points x, y that make the equation true. So as an example, if I had this equation, the combination x equals 1 and y equals -1. Right? What happens if we insert those numbers? We would have -1, which is y, equals 1 squared minus 2 times 1. And we get that this is true. So we can observe that this combination of values makes the equation true. There are a lot of other examples that would make the equation true. Maybe I would have y equals 15 and x equals 5. Does that make the equation true? We would have 15 equals 5 squared minus 2 times 5. And yes, that makes the equation true. What if we had x equals 7 and y equals 3? 3 equals 7 squared minus 2 times 7. 3 equals 49 minus 14. This is false. So what we're doing here, little by little, is we're saying some points will be on this graph and some points will not be on this graph. So what we've learned here is that the point 1 comma -1 is on the graph. The point 5 comma 15 is on the graph. The point 7 comma 3 is not on the graph. And in theory, there are patterns, right? We could plug in a lot of different points. We could test things. We could remember some rules from pre-calc or algebra 2 or algebra 1 about how some of these graphs are supposed to look. Right? When we put this all together, and I'm just going to draw a very rough picture, for this particular example, we will get a parabola. There are infinitely many points on this parabola. We already know a couple of them. We already know that the point where x is equal to 1 and y is equal to -1 is on that parabola. We already know that the point where x is equal to 5 and y equals 15 is on the parabola. We can observe that the point where x equals 7 and y equals 3, that's not on the parabola. So there's this relationship between graph and equation. And what I want to say here, right, this statement here is, for some students, it feels almost meaningless, but if you truly understand this, it'll allow you to have the right perspective on certain problems. So if a point makes the equation true, then it's on the graph. And if a point is on the graph, it makes the equation true. Right? So what this means is if I tell you, hey, here's a point, and I'm not going to tell you its exact coordinates. I'm just going to say it has an x coordinate called A and a y coordinate B. Well, here's what we know. And I realize I'm not giving you a ton of space here for taking notes. Maybe you just want to think about this one. Not everything needs to get written down because the main idea is written down here. Oops. But here's what we know. We know if x equals A and y equals B, the equation we've been talking about is true. And remember, our equation was y equals x squared minus 2x. So that means we actually know y, which is b, equals x squared minus 2x. We're being very abstract here. I don't know what those numbers are. But from the mere fact that this point is on the graph, I know that this algebraic fact is true. This is very helpful for doing problems. If you see something on the graph, there is an algebraic fact you know is true. If there's an algebraic fact you know is true, you know something about the graph. This feels like I'm just kind of talking in circles, but it really is the key for doing certain problems. And I will also remind you that you know you've encountered a lot of functions and graphs that you're supposed to know what they look like, and maybe you forget. If you truly understand that the graph is just a reflection of an algebraic fact, you can recover some of them, right? So maybe you've forgotten what does the graph of y equals the square root of x look like. Okay, if you've forgotten, try to think of some examples that make this true. Oh, well, if x is 9, y is 3. If x is 4, y is 2. If x is 1, y is 1. If x is 0, y is 0. I'm doing this very quickly to illustrate a point. Don't feel like you have to copy all of it. So you could say, oh, there's a point at 9, 3. There's a point at 4, 2. There's a point at 1, 1. There's a point at 0, 0. And then maybe you'll remember, oh yeah, one of my basic graphs kind of looks like that. This is so much better than just guessing. Some students just memorize, oh, I'm going to memorize that the square root graph looks like this, without any sense of why that's true. It's true because being on the graph is the same as making the equation true. And then let's just remind ourselves, if two graphs intersect, then the point of intersections makes both of the equations true. So just as a little example, let's draw this same example as before. So in green, I will draw a rough picture of this parabola. The green one is y equals x squared minus 2x. And now in pink, maybe I could draw the line just y equals x. From the picture, we see there are two intersections. Definitely know how to do this on your calculator, but you should also understand how to approach it by hand. At this point, right, this point right here is on both graphs. So it makes this true, and it makes this true. Both are true. At that point, right? Not everywhere, but at the points of intersection, both of these equations are true. So what that means is at that point, we know that y is equal to x squared minus 2x. But we also know that y is equal to x. Both of these facts are true, so you can write them down. So what this means is if we just eliminate the y, x is equal to x squared minus 2x, which means 0 is x squared minus 3x. I'm going to solve this by factoring. So either x is 0 or x minus 3 is equal to 0. So either x is equal to 0 or x is equal to 3. Then to find the corresponding y value, I could use either one of these. Right? This is easiest because it says at those points, this equation is true and it says y and x are the same. So one of the points would be at 0, 0. And one of the points would be at 3, 3. And that should seem believable from this picture. Some people just memorize, oh, I set them equal. But we set them equal because when we have a point that is on both graphs, this fact is true and this fact is true. And combining them gives us some really specific information.